Hi, everybody. Welcome to the Algebra 1 CBA review. In numbers 1, 2, and 3, they ask us to find the domain and range. But as we can see from these three problems, they are all very different. One is a horizontal line. So we can look at our domain and range as our x values for domain and our y values for range. So when I look at my domain, I see, 0 has a point right here, and 1 has a point right here, and 2 has a point right here. Every single x value I can think of, even if I thought about what would happen when x is 10, like all the way over here, my graph's going to be right there. And what happens at negative 20? My graph's going to be right there, because these arrows mean that I extend horizontally in both directions forever and ever and ever. So my domain then would be all real numbers from negative infinity to positive infinity. We can also see that written out in words, that it actually will say all real numbers. Our range is a different story, because if I look at this and I'm saying, how low do I go? How high do I go? My graph is actually kind of boring here. It's at 3, and then it's at 3, and then it's at 3, and then it's at 3, and it's never going anywhere else. So I can't really write my range like I do normally for continuous functions. I have to just write my range as 3 because it's not anything else. So I'm going to write it in these braces and just write the number 3. Number 2 is a discrete graph. So when I write my domain and range, it's just in these braces again, and it's just a list. List out the x values from least to greatest. So negative 3, negative 2, 1, 2, and 5. And for my range, same thing. I'm just listing from negative to positive, or from lowest to greatest, least to greatest. What am I saying? Negative 5. Then I have 0. I have 2 that are at 1, so I'm just going to write that one time. It's not negative 1. Oh, no. Okay, 1, and then 4. It's okay that I have 5 domain values and 4 range values. That's totally okay. Number 3 is another continuous graph, but it's a little more interesting than just this horizontal line that we had. For this graph, I see that, again, I have arrows, and they are facing up and kind of out. So I know that my graph would continue up and out, up and out, up and out, and in this direction as well, up and out, up and out, up and out. So it goes all the way to the left and all the way to the right, making my domain the same thing, negative infinity to positive infinity, or we could also write all real numbers. Okay, and my range, again, not so easy. I can see that it goes down until we get to negative 2, but it never goes below negative 2. It touches at negative 2, but never goes anywhere below it. So we could say that we go to negative 2 and then up to infinity. Another way you could see this written is all real numbers greater than or equal to negative 2. Okay, the next section is factoring. So I have a quadratic trinomial here. So I'm going to label my A, my leading coefficient, my B is the coefficient on my linear term, and my C is my constant. So A times C is 27, and I'm going to list out my factors. So 27 is 27 times 1 and 9 times 3. If I add, I get 28, and if I subtract, I get 26. If I add, I get 12, and if I subtract, I just get 6. And that's exactly what I was looking for. My B value is actually negative 6. So now I have to think to myself, how do I get negative 6 from 9 and 3? Is it 9 minus 3 that's negative 6? Or is it 3 minus 9 that's negative 6? It's 3 minus 9. 9 minus 3 is positive 6. So when I write out my 4 terms, and I'm going to factor by grouping, I'm using a positive 3 and a negative 9. Now, I could do this the opposite way. I could put the negative 9 first and then the positive 3, but it doesn't matter. All right, listing out my factors. X squared is x times x. 3x is 3 times x. Grouping. The GCF right here is x, and I'm left with x plus 3. Now, negative 9x can be written a few different ways if I factor it, if I break it down into its multiplication. But I'm going to make it negative 9 times 1 because I can also write negative 27 as negative 9 times 3. Now they have a negative 9 in common, and I'm left with x plus 3 again. And that's exactly what I wanted. I wanted both of these parentheses to match each other because that's how we do factor by grouping. Now my final answer is x minus 9 times x plus 3. And you should notice that this negative 9 is this same negative 9. And this positive 3 is still that positive 3. Okay, so same thing with number 5. I'm making my A a 1, my B is an 8, and my C is a 15. And so A times C is 15. There are 2 possible factors to give me 15, or pairs of factors. It's 15 and 1 and 5 and 3. So we add, we subtract. We add, we subtract. And what I'm looking for is this B value, which is 8. That's under the plus column. So I know the signs need to be the same, and they need to match the B. Well, the B is positive, so they're going to be the same. They're both going to be positive. So t squared plus 5t plus 3t plus 15. And again, just like the last example, you could put the 3t first, or you could put the 5t first. That part doesn't matter. So I have 4 terms. I'm going to factor by grouping again. I'm going to kind of split this in half. This is tt. This is 5t. This is 3t. This is 5 times 3. Now, I chose to write 15 as 5 times 3 and not 15 and 1 because I want a GCF. I want something that's the same in both of these terms so I can circle it and factor it out. So my GCF here is t. I'm left with t plus 5. My GCF here is 3, and I'm also left with t plus 5. Fantastic. So my final answer is t plus 3 times t plus 5. And you should notice that those are the same numbers that I got right here with my 5 and 3. All right, ready for the big one now. 6e squared plus 1e minus 12. A, B, C. So my A times C is 6 times 12 this time, 72. So I'm going to add, I'm going to subtract. I have a longer list this time. So I know that 72 is 72 times 1, and I add and I subtract. I also know that 72 is 6 times 12 because that's how I got it in the first place. So adding those together is 18 and subtracting is 6. I'm looking for 1. I haven't found it yet. Also, I know this is 2 times 36. Which added together is 38 and 34 when you subtract. Okay, that's not it. Whoops. 34. Also, I have 4 times 18. That is, 4 times 18. Yeah, that is 22 and 14. Yeah, that's not going to work. And what else? How about 9 times 8? That's 17, and that's 1. There we go. So I'm under the minus column, which means that my signs are different. So is it 9 minus 8 that gives me 1, or is it 8 minus 9 that gives me 1? Well, we know I want a positive 1, so 9 minus 8, of course. So I'll have to finish this in the next video because I'm out of time.